Kia ora Year 12 and Year 11. I'm going to YouTube the excellence questions from Level 2 papers that I haven't done yet. I'm starting with question 1F, which is a kinematics one that Padraig asked me about. So this one is one where we're given the distance formula. So during a fundraising cycle ride, the distance S kilometres of a cyclist is modelled by this function. And T is the time in hours since he passed some fixed point. So we're asked how far will the cyclist be from the fixed point when he reaches his minimum speed. So this is a nice question that just tests whether students understand what's going on with kinematics. We start off with displacement or distance from the fixed point, and we differentiate to work out speed. So I'm going to do that now. V of t will be 3 times 0.1875 t squared minus 2 times 2.5, which is 4.5, so 4.5t plus 21. So that's my function for speed, but we want to find the minimum speed. So to minimize something, we differentiate and we set that equal to 0. So what we're trying to do is find when is v dash of t equal to 0. And we know that that's the same as the acceleration function. So we can write it either way. We could write v dash of t, or we could write a of t, and we're going to get, let's first of all clean up what we had here. So v of t was 0.5625 t squared minus 4.5t plus 21. So its derivative will be 1.125 t minus 4.5. We set that equal to 0, giving us 4.5 over 1.125 is equal to t. So t is equal to 4. So that tells me when he will reach his minimum speed. And now we need to work out how far he will be from the fixed point. So we take 4 and we sub it back in to the displacement function. So we're working out s of 4, which is, I'm actually going to let you do the substitution, because if you're watching this video, that's probably the easiest step, and that works out to be 60.5 kilometres. So there you go. It's a pretty easy kinematics one for excellence, I reckon. I'll be back with some other ones later on today. Thanks for watching.